So this is a video explaining the process for the day 14 notes, where the focus is to take a look at a graph of a function and write a sine or cosine function that matches that graph. And what we'll see as we get into the notes is, although the graph will look like it's one or the other of sine or cosine, you can actually write a sine or cosine function for either of these, and I'll explain that process here in a second. So if you take a look at this first example, or the first graph in the first example, there's a couple things I want to identify about the graph so that I can write the equation. One of them would be the amplitude. So if you look at this picture here, from the highest point of 3 to the midline at the x-axis, that's a distance of 3. So my amplitude will be 3. And then if I want to identify the period, this is one full period of what looks like a sine graph. So if I look at this picture from 0 to 2 pi over 3, that's one complete cycle. The function returns to a value of 2 pi over 3, so the period would be 2 pi over 3. And then if we want to think about writing an equation for this, I'm going to color over it, so I'm going to write an equation for this graph here. In my function, I have to find the b value, which is what helps me get my period from 2 pi to 2 pi over 3. So the way you do that is you take 2 pi over b and set it equal to what your period actually is. And in this case, if you look at these two fractions, the only way they'll be equal is if my b value is 3. So looking at this function here, I have an amplitude of 3, a period of 2 pi over 3, which means my b value is 3. And with those two pieces of information, I can write a sine function for this graph. So my equation would be y equals 3 sine of 3x. 3 out front is the amplitude, the 3 on the inside of the function is my b value, and there's my equation. But like I said before, I can actually also write a cosine equation for this graph. So if I erase this purple one here and I think about starting up at 3, in order for this to be a cosine graph, I would have to extend my graph a little bit beyond what is originally graphed. So if I look from the x value of pi over 6, I'm up at the value of 3. And to finish one complete cycle, I would have to add one more tick mark on my x-axis, which takes me to one full period of a cosine graph. So if you look at the red scribbled part there, you can see that that is what looks to be one complete period of the cosine graph. So if I want to write an equation for this, the amplitude and the period will actually be exactly the same as the sine graph. They're the same graph, so they should be. That makes sense. But what will be different is, in order to get my cosine function to look like this, what I mean by look like this is, have a maximum at pi over 6 rather than at 0, there's actually a phase shift happening here. So there's a phase shift of pi over 6, because usually cosine either starts at its highest or lowest value on the y-axis. So to get my maximum to be from 0,3 to pi over 6,3, that's a phase shift of pi over 6. So if I think about how that's going to change my function, it'll still be y equals 3 out front, cosine. But now, if you look at what I wrote here, I'm going to separate my b value, which is going to be out front of my quantity, and inside that interior set of parentheses will be the notation for my phase shift. So in this case, I'll have a 3, which is my b value out front, and then on the inside of my function, in the inside of that set of parentheses, I want to write something that will move my graph to the right pi over 6. And what that'll be is x minus pi over 6. So if I look at this cosine equation that I have here, that cosine graph is for that red portion, and the sine graph I wrote previously in purple, they're the same graph. They differ by a shift of pi over 6. And cosine and sine in general are just one phase shift of each other. If you think about the unit circle, the coordinates on the unit circle are the same for sine and cosine, just in different places. So that's kind of what's happening here, is I can write a sine or a cosine function depending on what part of the function I'm looking at. One will probably be a little more straightforward than the other. If you look at the sine graph, it was a little bit more straightforward or the sine equation was a little bit more straightforward to write because I didn't have to consider a phase shift, but in reality, either of those are equally correct. So if you look at the second example, or the second graph in example 1, I want to do the same thing. So I'm going to identify the amplitude and the period even before I decide what type of function I'm going to write, because the amplitude and period will be the same whether I call this a sine function or a cosine function. So the amplitude in this case would be 2. The distance from the highest point to the midline is 2. And then the period will be, actually, I'm going to look from maximum to maximum. You could look from minimum to minimum if you kind of extended this graph a little bit, but the period in either case, however I decide to look at it, will be 4. So once I have my period of 4, what I'm going to do is kind of color over the part of the function that I want to write an equation for. So if you look at that piece that I colored over, that looks like a cosine graph. So really the information I have right now is y equals 2 cosine of something, I'm saying something blank x. The reason why the coefficient out front is positive is because this little portion that I colored is a cosine graph. It is starting above the midline in terms of what I colored, so the coefficient out front is positive. But what I need to figure out is the b value that gives me a period of 4. So the way I would do that is set up the equation 2 pi over b equals whatever my period is. So if I want to solve this equation, multiply both sides by b, so I get 2 pi equals 4b, which means 2 pi over 4 is b, so b is pi over 2. So that pi over 2 is going to be the coefficient of x that makes my period 4. So if I want to write my cosine equation, I have it right there. If I want to write a sine equation, I'll just erase what's on there, and then I'm just going to color over a portion of the graph that looks a lot like a sine graph. So from 1 to 5 is still a period of 4, still an amplitude of 2, so that information hasn't changed. But what will change is in order for me to write the equation for this kind of red colored part of my function, it'll be a sine graph. I know that because the part I colored starts on the midline and then ends on the midline, so I'm going to write a sine equation for that. So what's going to be different is, in order to write this sine equation, instead of the function beginning at 0, 0, it's beginning at 1, 0, at least the part that I colored. So in order to get to that value of 1, 0, it's a phase shift to the right of 1. So what I have in my equation so far is y equals, and now notice the coefficient is negative, because if I'm looking at this portion of the graph and calling it sine, this graph goes down first, then up, which means my coefficient should be negative. So I have negative 2 sine of, and then I'm going to go straight to kind of a number out front of a set of parentheses. So the number out front is my b value. Inside the set of parentheses will be my phase shift. So my b value is the same as it was in the cosine graph I wrote, because it's the same graph. But what will be different is that phase shift. So in order to mark out a phase shift to the right 1, inside my parentheses should be x minus 1. So if you could check me if you, on a graphing calculator or Desmos, you graphed both of those functions, they would be exactly on top of each other because they are the same. It just depends on where I'm starting to look to what type of equation that I can write. If you look at this next example here, example 2, again, you could look at it and say, oh, that looks like a sine graph, and the one next to it looks like a cosine graph, and you'd be right. You can write an equation for it, but you could write both. You could write a sine or cosine for either of these. So I'm going to show that. So if you look at this first example here, I'm going to identify the amplitude, and the amplitude is 4. And then I'm going to identify the period. So from 0, 0 to 2 pi 0, those dots I put on the graph, that's one full cycle of this graph. Therefore, the period is 2 pi. So if the period is 2 pi, that means my b value is 1. Because to find b, it's 2 pi over 1, or excuse me, 2 pi over b equals your period. So b has got to be 1 in this case. So again, if I want to decide what type of function I want to draw, I'm just going to color over the piece of the graph that I have. It looks a lot like a sine graph. So what I have so far is y equals, and I'm going to put my amplitude out front, 4. The only difference here is this, if I'm calling it a sine graph, it's going to start at 0, 0 and go down first, which means my coefficient should be negative. So negative 4 sine of x. Because b is 1, you could write 1x out front if you wanted to. It's not necessary, but it's the same thing. So y equals negative 4 sine of 1x, or x, is the graph of this function if I'm calling it a sine graph. Now if I want to call this a cosine graph, there's a couple ways you could approach it here. So let's say I begin by looking at this first minimum that I see to the right of the y-axis. In order to finish one full cycle of cosine, I would need to extend my graph here a little bit, so it looks something like that. And if I want to write an equation for this part of the function, color over it in green, that would be a cosine function. So if I think about the amplitude should be the same, it's the same graph, the period should be the same, which means the b value is the same. The only thing that's different is, in order to call this a cosine graph, I would have to consider this a phase shift of a sine graph. So from 0, on the y-axis, which is an x value of 0, to the minimum that I'm starting to look at, that's a phase shift to the right of pi over 2. So to write this cosine equation that would model this function here, my coefficient should be negative in this case because cosine has a phase shift of pi over 2, but this function starting below the midline and then going up from there, so it's a negative 4 as my coefficient. And then what I'm going to write is cosine times 1 times the quantity. So 1 is my b value. You don't have to write it if there's a 1 there, but I'm just going to write it just so you get in the habit of putting that value there. And then inside that interior set of parentheses, I need to put something that would move this graph to the right, pi over 2. And what that would be in this case is x minus pi over 2. So that sine function and this cosine function are the same graph. Notice that they're just they differ by a phase shift. In this case, one unit on my x-axis, which is pi over 2. Now, I'm not going to write another function for this, but I just want to point out that these aren't the only two answers. I could write another sine function or another cosine function depending on where I am looking at my graph. So just quickly, if I erased this green function that I had, and let's say I wanted to consider a cosine function, but I wanted to write an equation for this part that I have colored here. Notice that it is still a period of 2 pi, still has an amplitude of 4, but now if I think about what this would look like as an equation, it would be a phase shift to the left, pi over 2. So if I think about writing an equation for this, it have the same amplitude, same period, but this equation would have a positive coefficient because it's starting above the midline and going down, and have a phase shift to the left of pi over 2, but I'm not going to write that equation. I just wanted to point out that there are more than two answers. You could think about this periodic function, since it does go forever in both directions. There are lots of different answers that you could write, but I'm just going to go back to the green function here for my cosine, just so you have that as a reference. If you look at this last one, this last example, part of example 2, if I want to think about writing an equation for this, I could write a sine or a cosine equation, but the amplitude and period are the two things I'm going to identify first. So the amplitude in this case is 2. And then the period, be careful here, there's definitely more than one period drawn of either sine or cosine, so I have to be specific about where I'm looking. So if I looked from this maximum on the y-axis to the maximum at pi, that's a period of pi. So the b value that gives me a period of pi is 2. So those two pieces of information are going to be the same regardless of whether I write a sine or cosine function for this. But if I'm looking at from this maximum to maximum, this graph starting on the y-axis, I'm going to write a cosine function for this first. So y equals 2 would be the coefficient because cosine starting above the midline going down. And then cosine of 2x. And that's it. So that's the graph of this if I'm thinking of it as a cosine equation. I could also write a sine function for it. So I'm going to pick a sine function so that I have a phase shift to the left, because all the examples we've looked at so far are phase shift to the right. So if I look at this blue sine period that I've drawn here, this would be a phase shift to the left, and my notation should demonstrate that. So my amplitude is still 2, my period is still pi, which means my b value is still 2. And my coefficient in this case should be positive because my sine function that I have drawn here starts on the midline, then goes up. So what I have so far is a sine function shifted to the left, and what that would be in terms of that shift is pi over 4. So I wanted to just kind of show that if each line is every 2 lines is pi over 2, then each line should be pi over 4. And if it's to the left, I'm going to shift this to the left. So the equation that I would write is y equals 2, it's positive 2, sine of, and then I'm going to kind of put a blank number out in front of a set of parentheses. So the number that should go out in front is my b value, which is still 2, but on the inside I want to write something that would shift my graph to the left pi over 4, which in this case would be x plus pi over 4. So that's a sine function or a sine equation for this graph, and there's a cosine equation for this graph as well. Now if you look at this U-try, I'm going to go through these a little bit quicker. I'm going to pick one equation or the other because I've already walked through the process of writing both. So I'm going to kind of write the one that'll be a little bit more straightforward, but you could write a sine or a cosine equation for this. So the amplitude in this case is 2. The period is 8 pi. So I marked the beginning and end of this period with a dot there on the x-axis. So if I want to write an equation for this, and I'm calling it sine, just because it starts on the midline, goes up, down, and then finishes back on the midline, sine would be the most straightforward. So I'm going to color over that just so I'm clear on what I'm writing an equation for. In order to get a period of 8 pi, I would do 2 pi over b equals 8 pi to solve for my b value, because that's what's going to go in my equation. So if you look here, how I solve that, I would multiply both sides by b and then get b by itself, so divide both sides by 8 pi, and what I get is a b value of 1/4. One way to think about it is if my period was 2 pi regularly and now is 8 pi, that's 4 times as long, which means my b value should be 1/4. Because if you remember back in chapter 6, coefficient of x is 1/4, it stretches my graph out. If my coefficient in front of x was 4, it would compress my graph. I don't want to make this too complicated to find. You could always set up the equation, but just thinking about how this connects to chapter 6, that's why my b value is 1/4 instead of 4. That's a common mistake. We'll just call it 4 because it's 4 times as long. Now if I want to write an equation for this, it'd be y equals 2, positive 2, because my graph goes up first from the midline, 2 sine of 1/4 x. And since I'm calling this a sine graph, I don't have to consider a phase shift of any kind. That would be my equation there. And then look at this last example in the U-try section of the notes. The amplitude would be 3 from the midline to the top, and then the period would be 4 pi. So from the y-axis to the end of this one period shown would be 4 pi. So I'm going to color over the part that I'm going to write an equation for, and I'm going to write a cosine equation for this because it starts below the midline and goes up and then finishes below the midline. You could also write a sine equation, but I would have to kind of extend my graph one way or the other to finish that. So if my period is 4 pi, I would find my b value. 2 pi divided by b equals 4 pi. b has to be a half. So if I want to write a cosine equation for this, my coefficient should be negative because my graph starts below the midline. So y equals negative 3 cosine of 1/2 x. And that's my cosine graph there. That would fit this. Again, if I wanted to write a sine graph, I'm just going to kind of extend the right side of this and just kind of make a dotted function over this and kind of go through it a little bit quicker. To write a sine function for this, it would be a phase shift to the right pi. If I want to think about this being a sine graph, I started at pi on the x-axis and went all the way to 5 pi to finish one period. So it's a phase shift to the right pi. My b value is still the same. In this case, my coefficient is going to be positive because this sine graph that I've kind of dotted over in red goes up first. So it'd be 3 sine of 1/2 times the quantity, and inside that set of parentheses I need x minus pi to shift this sine graph to the right pi. Both of those answers are acceptable. You could have also extended your graph to the left and written a sine function that way. Lots of different options here. I just want to kind of give you both on that one. And then example 3, when it says evaluate, really that just means find a value, a number, answer. So if I want to find a value for a, I'm going to have to add cosine of 7 pi over 6 to cosine of pi over 2. Now the good thing about cosine of 7 pi over 6 is 7 pi over 6 is an angle we should recognize on the unit circle, which means we should know the coordinates of that angle, and cosine would be the x-coordinate of the angle 7 pi over 6. So cosine of 7 pi over 6, if we know where that is on the unit circle, would be negative root 3 over 2. Cosine of pi over 2 would be 0, so if I want to add those values together, it'd be negative root 3 over 2 plus 0, which is negative root 3 over 2. That's the value of that expression. Just by knowing where those angles are on the unit circle helps me find those values, and I can find my answer there. For part B, I'd do something very similar, but now I'm multiplying these two values together. So sine of pi over 6 is 1/2. And then cosine of 3 pi over 4 is negative root 2 over 2. So if I want to multiply these two values together, just multiply across the top and across the bottom, I would get negative root 2 over 2. Or excuse me, negative root 2 over 4. That's the final answer. In some cases, people will want to kind of reduce that or simplify it. The 2 is inside the radical, 4 is not. You can't reduce those at all. So my answer would just be negative root 2 over 4.